Hello, everyone. Welcome to this session. I hope you guys are having a great day with jam-packed sessions on Data Exposed. So right now, I'm Abhishek Narain, and I work as a program manager in Data Factory team. So in this session, we'll be talking about data security best practices for data engineers using Azure Data Factory. So let's get started. So before we get started and talk about all the security considerations, I think we need to talk about access control model in Data Factory. And so we'll talk about typically how the access control model works like is you have a single data factory and there is an access control on that. And so give me a quick second. Yeah, so that's how the ADF access control works. And so give me a quick second, please. Okay. Yeah. So we'll talk about authentication. And authentication is basically ADF supports multiple types of authentication while connecting to different data stores. Windows authentication, basic auth, service principal, and managed identity. And we'll talk about managed identity as well. Managed identity in particular, we'll talk about that. And in terms of network connectivity, we have managed virtual network, which we have talked about before, which kind of gives you a security isolation, network security isolation in terms of the compute infrastructure. And then we have ADF private link as well. So what ADF private link does is it provides you, think of control plane access, having securely accessing the control plane using the private link. So that's what it does. And then we'll talk about a few more things about metadata encryption, like encrypting the metadata of Data Factory, and that too using things like customer managed keys. You can use customer's own key. You can bring your own key to encrypt the metadata that is stored within Data Factory. Then we'll talk about credential management on how ADF gives you different ways to bring in your credentials in the link services. And then also different options that ADF uses to store these into these credentials and secure these credentials, right? And we also touched upon the access control model is single data factory has its own access control. So typically we suggest customers to use a single data factory for a project so that all the artifacts within that factory, all the link services, data sets, pipelines will be shared across with all the people who are part of that access control. Right. Okay, so let's get into the details. Now, we'll talk about a very interesting topic, which is building password-free data pipelines. And that's something which you can achieve with the MSI authentication. So in the previous slide, we did talk about different authentication types that ADF supports while connecting to different data stores, like Windows Auth, the basic auth, the service principal auth, and the managed identity auth. So we will dig deeper into the managed identity auth, which is very specific to Azure Active Directory. And especially when you're building native pipelines on Azure, this comes very, very handy. So if a particular data store supports MSI auth, which is managed identity authentication, it's an Active Directory feature, which kind of helps you get rid of password. Think of this as a biometric. Like think of how you log in into your iPhones or an Android phone using biometrics, using fingerprint. Similarly, you don't have to actually really put in a key in your pipeline somewhere, like credentials and stuff in your pipeline. It's more used for a service-to-service authentication, like ADF as a service being trusted to access a particular data store, and that's what you can achieve using this. So if a data store supports MSI Auth, which is basically supported by all Azure data stores, you can enable this MSI Auth, which means your passwords, your data factory will not be storing any credentials at all. It will be a trust between data factory service and the corresponding data store. If by chance your data stores do not support MSI, for example, on-prem Oracle or on-prem data stores might not support MSI authentication. In those cases, you can always put in the credentials in Key Vault. Key Vault is another storage or in another service on Azure where you can safely bring in and secure your keys there. And ADF can access the keys from the Key Vault during the runtime. This helps as well because you're actually creating a pipeline which is still passwordless, because the Key Vault contains the key, which is outside of the scope of the data factory, the security model that we saw here, the access control and stuff. So the credential still does not live inside the data factory. It still lives in your Key Vault, and ADF references it using the MSI auth. It kind of creates a trust relationship and then fetches the key during the runtime. So that's the benefit of using managed identities. Managed identities are managed by Azure, so you really don't have a problem of kind of securing this managed identity. It's a Microsoft managed. You can think of as a managed password, which is completely managed by Microsoft, and it only basically there's no zero credentials at all in this case. So hence it's more secure, and especially for data stores which supports it. And for data stores which do not support it, you can still have this capability by putting the credentials in Key Vault and then getting those credentials during the runtime through the ADF pipelines. So that was the first one. We talked about authentication. In coming back to the slide, we talked about authentication. Let's move to the network again. So from the network security or strategy, data access strategy side of Data Factory, here's a quick table for the reference. You can go through that later. But what I want to touch upon on this slide is the most secure way that you can use Data Factory to access your data stores is using private endpoints. So you can use private endpoints. Private endpoint is basically a way how you can access your data stores, past data stores on Azure, in a more secure fashion with all the data exfiltration stuff capability built in it. So it's a private connection, or basically it's as good as saying that you're bringing the service inside the managed VNet. And so you don't have to open up any public endpoints into your data store for data access. So that's the benefit that you get with the private endpoints. And the second thing I would talk about is, in case if you're not using, so the first feature, which is private endpoints, is part of the new offering, which is in preview, which we call it as managed VNet. So if you're using that, well and good. You can also use self-hosted IR. Self-hosted SHIR stands for self-hosted IR. You can also use that. You can provision a self-hosted IR in your own virtual network or your on-prem, and you can still use private endpoints if your on-prem is connected to Azure network through which it can access private endpoint, or it's in Azure virtual network through which it can access private endpoint. It can work as well, and that is something which is already in GA, and you can use that. The second option that you have is, private endpoints is by far the most secure because the data doesn't ever move out into public internet, right? So it just goes through the private endpoint directly into the service, and that too directly into the service instance. So it solves the exfiltration problem as well, which service endpoints earlier suffered from. And then the second point is the static IP. If you're using self-hosted IR, and if you want to connect to, let's say, Amazon S3 or a PaaS database which is outside of Azure, SHIR can help. It can get you a static IP, which can be used to whitelist in the firewalls of the corresponding data stores, and through which you can access that. So it still is a 1:1 whitelisting that you're doing. The data still flows through the public internet, and hits the public endpoint of your data store, but it's still secure because you're not allowing everyone to access it, but for a particular IP, which is held by you, because SHIR stands for self-hosted IR, which is running on your infrastructure. And hence you get a IP of your own infrastructure either, or something on Azure, or maybe a fixed static IP that you already have on-prem. The third way is using static IP range, and this is particularly useful for Azure integration runtime. When you're using that, you can get a static IP range, which can be whitelisted in the corresponding data stores. There is corresponding service tags as well. If you're whitelisting it in a firewall or something on Azure side, you can use service tags. If you're whitelisting it on Amazon side or different cloud side, you can use the static IP range. It's listed out there. Then the fourth option, which is trusted service firewall exception, which is applicable for storage, which is applicable for Key Vault, can be used when you're using MSI Auth with Azure IR. So that's also one way, and it's in different order. So I would say first is the most secure, second a little less, and so on. So that's the order of this. And of course, the final one is the public endpoint, which basically says that on each data store, if you allow all services to access that particular data store, you're kind of using the public endpoint. And of course, both the IRs, Azure IR and SHIR can work in that way, but that necessarily is in the most secure form in terms of data access strategy. Okay, moving further, we talked about, again, on network security, the story around the managed VNet and how it's more secure using the private endpoint. And this slide kind of illustrates that point. So you can see there's an Azure managed elastic infrastructure, which is accessing the different private endpoints. And each of these private endpoints correspond to a managed PaaS service like SQL DW or Synapse Now or Azure Storage, which do not have public internet access on it. So you can still access your storage securely from the managed VNet using private endpoint without having to expose any public endpoints to your storage or data warehouse. That's one of the benefits here. Now, you can also extend this model to access IaaS hosted data sources or on-prem data sources like SQL Server on-prem, as long as you have a line of sight of connectivity from Azure to your on-prem data source. So you can build your own private link service. You can build your own PLS service with a load balancer and with a NAT logic. NAT is network address translation. So these VMs, what they do is it translates the network addresses, the IP addresses of your SQL Server. And whenever there's a packet coming in from this Azure IR in the managed VNet through this private endpoint, it kind of bounces it to the on-prem SQL servers. This is absolutely secure. Because this is all living in your subscription, controlled by you, and you will open up one by one. Basically, it's a natting that you have to do, and so natting is done per data source. So it's not really opening up all the data sources on-prem, but you have to create or set NAT entries per data source that you add. So it's pretty secure, and you can get it approved by your networking team, and then make on-prem work as well with the Azure IR in managed VNet. Okay, now quickly, let's talk about encrypting the metadata. This is more on that point on metadata encryption in ADF, which is when you write a pipeline, the link service, the data set, all these artifacts that are created using the UI, using the visual UI, how do you manage all of them? And so for that, you have two ways to do it. By default, Azure will encrypt all your metadata, but you can also bring your own key and make sure that you do a double encryption. So on top of the encryption done by Azure, you can bring your own key and Azure will encrypt your data additionally with that key. So that's a double encryption that you get, and you can enable that. It's very easy to enable that as well. In the ADF UI in the Manage Hub, you can bring in customer managed key, add your key, give a key reference, and we can fetch the key. And every time ADF basically accesses your data factory artifacts and stuff, it'll use your key to decrypt and encrypt it. So even Microsoft cannot read the metadata that you have unless it gets access to your key. So anytime you revoke your key, you can imagine that even the service provider does not have access to your data. Okay, now there was a fourth point which talked about credential management, on how the credentials are managed in ADF. So before we get into that, so from the credential management side, we talked about two ways of managing credentials. One is you can put in the credentials in the link in the Key Vault and access it during the runtime from ADF. And in that flow, what you see on the screen does not apply at all. But in case if you're storing the credentials in Data Factory, there's a specific thing you should know about how the credential management works on integration runtime, especially the self-hosted. And this is how the registration flow of the self-hosted IR work on the left-hand side is when, you can see one thing which I want to call out here is it's all outbound only. There is nothing which is happening inbound, which means there is no communication that is happening from Azure to your on-prem network. It's always your on-prem network and the integration runtime reaching out to the ADF service. So making things much more safer and easier to get it through your security audits and stuff. And then in the creation flow, it works the same way out. Of course, we have to do some interaction, but the interaction is done in a different way. We use a service bus to kind of pull in the credentials. But in total, what happens is when you set up a credential, the credential is actually stored on the self-hosted integration runtime. And this is one of the security functionalities that we offer is when you're using a self-hosted IR and encrypting credentials on it. So of course, all these credentials, we treat them as secure string. And so anything which is a secure string, our service will always keep them encrypted using our keys, of course. And if you give your key, the CMK part, which we talked about earlier in the previous slide, we will do a double encryption of that. So what happens now is when you're using a self-hosted IR and let's say you create a connection, a link service to connect to on-prem SQL Server, what we do is we store the credentials, if you're not using Key Vault, on the self-hosted IR itself. We encrypt those credentials using Windows DP API and keep it encrypted locally. And here's an example of a link service payload encryption. So what you would see is this is what I mentioned, that in case if you want, what we do is by default, we keep some fields in the link service, let's say, server name, username, password. Those are the fields which we treat always as secure. But additionally, if you choose or if you want to make a particular thing like a table name as a secure string, you can always edit the JSON. The whole app model definitions in ADF works based on JSON. So you can actually view code next to any artifact that has been created in the UI, like the pipeline, the data set, the link services. And that is where you can actually go ahead and set, in your case, in your any property that you're using, like table names, you can additionally change that type to secure string. So the moment you change it from string to secure string, what ADF does is if you're using a self-hosted IR, it'll make sure it encrypts it and keeps it locally. So it doesn't even get exposed to the service on the cloud side. At the same time, if you're using Azure side of the things like Azure IR, we will, for example, the data set and stuff definitions are still stored on the cloud. And so what we will do is we will make sure that the table name will never be seen in plain text. Again, the moment you actually do a check-in, you store it as is. And every time that you access it, you will see it as a base 64 string, which means the value which you entered will never be shown again. Now, that's the benefit. This is how you can enable additional or a custom encryption on any property that you're declaring in your data set or your link services. We do hear this from a lot of customers. Like there is some, you can treat this as explicit versus implicit. There are some implicit encryption that happens already in link services. When, for example, when you create a link service, you will see when you open up or edit the code, you will see that JSON does not contain any credential at all, right? That's called implicit encryption. Every time we know that these are secure fields and we implicitly encrypt it. But in some cases, like in data sets, a table name is probably the best example. Some customers feel that even the table name contains some business insights, which they do not want Microsoft to see or anyone else to see. And hence, they might want to just even make sure that even the table names are secure string. So you can make it secure string this way. Any payload, as I said, in JSON, you can mark them as secure string, which means that no other user using your Data Factory instance, or even Microsoft, or even when you raise a support ticket, all these fields will always be hidden. Okay, I think that's all about it. What I will do is I will quickly recap all the points that we went through. These were the 6 points in terms of security considerations. We started off saying the security isolation is done per data factory. So think of it as if you have a requirement of a single project, you should use a single data factory. It should be a 1:1 mapping, because the moment you add multiple projects in a single factory, all the artifacts will be shared by all the users in that factory. You do have some roles in RBAC. For example, someone can only be a reader versus someone can be a contributor, which means they can write pipelines, but even the reader can do or see things like link services, not the credentials, but they can see things and they can actually do a few things like monitoring and stuff as well. So a real way of isolation is kind of move to a different factory, start a new project over there. So keep that in mind. Then we talked about the authentication type, and we talked about managed identity, how it stands out compared to the other different authentication options, even including service principal, because in even service principal, you do have to keep a few credentials and stuff, like the key of the service principal and the certificate in case if you're using that somewhere. So you still have to manage that. In case of managed identity, there's nothing like that. So in case then we talked about network, we talked about managed VNet and using ADF private link to make sure that even the data plane, the control plane access from SHIR to the backend of ADF happens through a private link service, which is more secure. And then we talked about metadata encryption using CMK to do a double encryption. Then we talked about different ways of credential management using Key Vault or using ADF service. And we always encrypt it, and you can additionally encrypt other fields in your payloads as well. And then a few things which we didn't talk about earlier is data in transit. All the data that moves from ADF runtime to your data store side. Of course, there's a HTTPS TLS encryption on the channel. So that's all for data in transit. And for data at rest, we suggest you look into the underlying data stores capability, because ADF as a tool does not store your data. It only stores your metadata. The data is actually stored by different data storage. So the capability has to be used for that particular data storage, like SQL or Azure Blob. All of them support encryption at rest. So just enable those for all the data stores. So I think that's about it. And we're done with the 20 minutes. And thank you. Hope you have a useful session, and look forward to seeing you in the future sessions as well. Thank you and have a nice day. Bye-bye.